Welcome back to my Cloud Engineer channel. In the part 1, I built and hosted a static resume website using S3, CloudFront, and Route 53. This week, I'm moving into the back end and building my first serverless API on AWS. The goal for this week was to create a backend that tracks a visit account using DynamoDB, Lambda, and an API gateway. Here's the high-level architecture. When someone hits my API endpoint, API gateway triggers a Lambda function. That Lambda function updates a counter in DynamoDB and returns the updated count as a JSON response. This is a classic serverless pattern and a great foundational for real-world cloud applications. The first thing I created was a DynamoDB table. This table stores a single item that holds the visit account. I use a simple partition key and initialize the counter to 0. DynamoDB is fully managed, highly scalable, and perfect for this use case since I don't have to worry about servers or capacity planning. Next, I created a Lambda function using Python. Now, I haven't done any practical work with Lambda using Python before, so I took a short course on Udemy. The course was called AWS Mastering Boto 3 and Lambda Functions using Python. Boto 3 is a Python SDK for AWS, which allows us to directly create, update, and delete AWS resources from Python scripts. I didn't go through the whole course, but until the video tutorial of uploading a JSON file to S3 and automatically processing the file to put it into DynamoDB, that gave me a good foundation to actually proceed with my project. This function does 3 things. It reads the current count from DynamoDB, increments the value, and lastly, it will write it back to the table. Because Lambda is event driven, it only runs when the API is called, which keeps the costs extremely low. This was my first time wiring DynamoDB directly into Lambda, and it really helped solidify how AWS services interact with each other. To make this work securely, I configured an IAM role for Lambda. This role only allows the permissions it needs, specifically access to read and update items in my DynamoDB table. This follows this principle of least privilege, which is critical in production cloud environments. After that, I created an API gateway endpoint and connected it to my Lambda function. Once deployed, this gave me a public HTTPS endpoint that I can call from any browser from my front end. At this point, the entire backend is fully serverless. A quick demonstration of how the counter is working right now. So if I go to API gateway, click on my visitor counter Lambda, visit counter, and this is the link. Here's the API in action. Every time I refresh or hit the endpoint, the counter increments. So it's from 7, 8, 9. The API returns a clean JSON response with the updated count. This confirms that the API gateway, Lambda, and DynamoDB are all working together correctly. This part of the project taught me a lot about event-driven architecture, IAM permissions, and security boundaries, how AWS serverless services integrate end-to-end. It also gave me more confidence reading AWS logs, debugging deployments, and fixing permission issues, especially when it came to deploying and testing code deployed to Lambda. In the next part, I'll be connecting this backend to my front end, adding proper error handling, and preparing the project for real-world usage. If you're also learning cloud or transitioning from on-prem to AWS, feel free to follow along. Thanks for watching. If this helped you or you're interested in cloud engineering, like and subscribe, and I'll see you in part 3.